Hello friends, welcome to Risingpearl.com. Today we are talking about series 12 where we are learning a great deal on areas related to circles. This is webisode number 6. Today we are going to focus on solving questions involving sectors and segments of a circle. This is part 1. So we are going to cover this topic of solving questions in sectors and segments maybe in 1 or 2 webisodes. So this is the first of them. Now friends, I hope you're following us along at risingpearl.com. In the last 2 webisodes, we looked at what do we mean by area of a sector and what do we mean by area of segments. I'm going to provide the video links below for your easy reference in case if you would need it. So let's take a look at the first question. Find the area of the sector of a circle with radius 5 cm and angle 30 degrees. Also find the value of the area of the corresponding major sector. Use pi equals 3.14. So first thing that we can immediately see is that we don't have a figure which is given. So why don't we draw first a figure. So here we have drawn a circle with center O, and I have taken any 2 points on the circle A and B. Let's name them A and B. Now these 2 points I have taken in such a way that if I join AO and BO, so let's do it, such that what is given is that this angle is 30 degrees. This is 30 degrees. And these two are the radius, and the radius is given to us 5 cm. So we have been asked to find the area of the sector. In the 2 webisodes ago, we talked about area of a sector. Let's write it here. Area of a sector is equal to pi r square divided by 360 degrees times theta, where theta is the angle subtended by the arc at the center of the circle. So, and we also noted that whenever we talk about sector, we are talking about the minor sector, because the arc AB, there is a minor arc AB and there is a major arc BA. So first we have to find out, whenever we talk about area of sector, we mean that it is area of the minor sector, which is this OAB. And then the major sector, that's why the question has 2 parts. We also have to find out the area of the corresponding major sector. So first let's find out the area of the sector. So area of our sector OAB will be equal to, so area of sector OAB will be equal to pi. R is given as 5. So pi 5 square divided by 360 multiplied by angle is 30 degrees. 30 degrees. So the 0 and 0 will cancel out, or this can be, so if you open up the parenthesis, the bracket, 5 square is 25 times pi. So 0, 0 cancels out, and 3 1s are 3 and 3 12s are 36. 1 by 12. So we have 25 pi by 12. This much centimeter square is going to be the area of the sector OAB. Now similarly, so area of the major sector, so we can do it one of the 2 ways. Sector, so you can take the entire area of the circle, the whole circle. If you take the area of the whole circle and you subtract this area of the minor sector, so you will get the major sector, area of the major sector, right? So one way, so let me just show it here. Let's just call this the first way. This could be area of the entire circle, which is pi r square minus area of the sector that we have gotten over here, 25 pi by 12. So if you solve them, you will get the area of the sector. The other way to solve this also can be, if we take this angle, and what is this angle? So this angle should be 360 degrees, 360 degrees minus 30 degrees, which is this, or 330 degrees. So simply you could also do that. It is, if you think about area of a sector whose angle is 330 degree, that will give you this entire area. So in that case, you don't have to take the whole circle, pi r square minus the area of the minor sector. So we can do this the other way, is pi r square by 360 degrees times the angle, which is 330. So it doesn't matter how you go about it. In both cases, you are going to come up with the same answer. I am not actually doing the computation for you. I know that all of you are smart enough to actually do it by yourselves. So this is the first type of question on sectors and segments, where they are really making sure, the question is making sure that you understand what is meant by sector. Let's take a look at another question, question number 2. Find the area of the segment APB as shown below. So we have a figure which is given to us. We have a circle with center O. 2 points A and B are taken. Actually, there are 3 points on the circle that have been given. And now we have to find out the area of the segment APB. So we have to find out the area of the part which is highlighted in blue. Again, in the last episode, we talked about what is area of a segment. So I hope that you are following us along at risingpearl.com. Again, I'm going to be providing the video links below for your easy reference. So the radius is given. The radius is given, which is 21. And angle AOB, this angle is given to us. So we have to find out the area which is highlighted in blue. Now, as you can see from here, and in this case, the question is saying we should use pi equals 22 by 7 instead of 3.14. So we are going to go with whatever is given over here for the value of pi. And like I have mentioned earlier along throughout this series, whenever the value of pi is not given, we are going to default to this 22 by 7. That means we are going to use 22 by 7 if we have not been given anything. So unless it has been given use 3.14, we are going to use 22 by 7. So now, like we saw in the last webisode, area of a segment can be thought about as area of the entire sector. So here what I have done, I have removed this straight line. So then we get the area of the entire sector, right? And then if we subtract the area of this triangle, then that will give us this part. So again, if you take the area of the entire sector highlighted in blue and minus or subtract the area of this triangle, if you find out the area of this triangle and subtract it, then we are left with this part, which is the part in blue. So area of a segment is equal to area of the sector minus the area of the triangle, right? So for us, in order for us to solve this question, we basically have to find out area of the sector OAPB, and then we have to find out the area of the triangle OAB and subtract the area of the triangle from the area of the sector. So that's it, friends. Now let's go ahead and find out the area of the sector OAPB. So OAPB is this. So we know R is given and we know this angle is given. So we know area of a sector is given by the formula pi r square divided by 360 degrees times theta. Or for us, what is given is pi, we are going to go with 22 by 7 times r is 21 times 21. This entire thing is divided by 360 times the angle AOB is given as 120. So 0, 0 cancels out, 12 3s are 36. So this basically is 22 by 7 times 21 times 21 divided by, we have 3 here. Now 7 times 3 is 21, so one of the 21 will cancel out. So we will have 22 times 21, this much centimeter square. This is the area of the entire sector. So now we are going to, let's clean this up. So now let's find out the area of the triangle OAB. Now how do we find out the area of the triangle? We are going to do a simple construction. What we are going to do is, we are going to draw a perpendicular from the point O. We'll draw a perpendicular on the chord AB. So for example, so if we do that, so let's say the perpendicular touches the chord at point S. So this is 90 degrees. Now here I am just taking one of the triangles. So here this is R, this is R. So if I just focus on this triangle itself, now I have to find out, we have to find out the area of the triangle OAB. We know that area of triangle OAB or any triangle is equal to half times base times the altitude or the height. So for us to find out area of triangle OAB, we need to know this height OS, right? So for us it will be half times OS, which is the height, times the base, which is AB. So now we don't know OS and we don't know AB. So how are we going to be able to find this area of a triangle? But what we do know is that if we just take a look at the triangle, so let's do one thing. So if we take a look at the triangle AOB, so if you look at triangle AOB, what we know is OA is equal to OB. So because both are radius, so this triangle AOB is an isosceles triangle. And that means that in isosceles triangle, angle OAB must be equal to angle OBA. So these two angles should be equal, because if I look at the whole triangle AOB, these two sides are equal, so these two angles must be equal. So now the sum total of three angles, this plus this plus this, should be equal to 180 degrees. So if I assume this angle to be, let's say, x, so what we have is x plus 120 degrees, which is this angle, plus x, sum of three angles, it should be equal to 180 degrees. So from here what we find out is 2x equal to 120 goes on the other side, so it will become 180 minus 120, which is 60. Or we find that x equal to 60 by 2 or 30 degrees. So in other words, each of these angles is 30 degrees. Now if I focus on the triangle OSB, it doesn't matter, you could have taken one of the two triangles, because we are not trying to find out OS, right? Now if you focus on this, what we do know is this is R and this angle is 30 degrees. Now at this point, friends, we are going to use trigonometry. We need to find out this OS. So what is the relationship between, because this is a 90 degree, because by construction we have drawn a perpendicular from O on to AB. So OS is perpendicular to AB. So this is a right triangle. OSB is a right triangle, right angled at S. Now, so we can apply trigonometry ratios. So because we have to find out OS and we have to find out SB. So first is, so what is the trigonometric ratio that involves the opposite side and the hypotenuse? It is the sine. So sine 30 degrees, meaning sine of this angle, can be written as OS divided by OB, and OB is the radius, which is 21. So in other words, what we have, friends, here is sine 30 degrees opposite side divided by hypotenuse. So OS divided by hypotenuse is the radius, which is given as 21. Or now we know that the value of sine 30 degree is 1 by 2. So from here we can find out that OS should be equal to, the 21 goes over here, so OS is equal to 21 by 2 centimeter. So we have found out OS that we need to know. Similarly, if we take cos 30 degree, that will be adjacent side divided by hypotenuse. So if we take cos 30 degree, it will be SB divided by hypotenuse, which will be the 21 degree, which is the radius. Now we know cos 30 degree is actually square root 3 by 2. In other words, what we have is, so SB is equal to, the 21 goes over here, square root 3 by 2 times 21, this much centimeter. Now if SB, because now we can also prove these two triangles are congruent, because this is 90 degree, this is 90 degree, these two are equal sides and this is a common side. So these two triangles are congruent by RHS rule. So this side must be equal to this side. So we have to find AB, the length AB. So AB is nothing but 2 times any one of the length. So we have just found SB. So now at this point we can write the area of the triangle. So area of the triangle will be equal to half OS. What is OS? OS is this value. So 21 by 2 times, what is AB? AB is 2 times either AS or SB. So if you take 2 times SB, you will get 21 times square root 3. 21 times square root 3. So this is the area of our triangle OAB. Now friends, I know that it has taken quite a bit to come up with the area of the triangle OAB, but everything that we discussed here is exactly how you're going to find out the area of the triangle OAB. So quickly to recap, you know the two radiuses are equal. So triangle OAB is an isosceles triangle. So if one angle is given, we can find out each of the other angles. So because this is 120 degrees, each of these angles is 30 degree. Each of them is 30 degree. Now that we have found out each of the angles, we will take a look at one of the triangle like this, and it is a right angle triangle. So because we know the angle, so we have one given angle and we have been given one of the sides, which is the radius, whose value is given as 21. So using trigonometry, the sine and the cos, applying the sine, we can find out the height OS, which is what we need. To find out the area of a triangle, we need the half base times height. So the height is OS. So which, using the sine, we can find out the height. And now to find out the base, we are going to find out first half of the base. Using the cos of the angle, we can find out SB equals some value. Now because these two triangles are congruent, AB is nothing but 2 times AS or 2 times BS. So because we know SB or BS, if we do twice, we can find out 2 times. So because the value is 21 times square root 3 divided by 2, so twice will be, the 2 goes over here, it will be 21 times square root 3. So at this point we know the value of OS and we know the value of AB. So the area of the entire triangle will be this, right? So 21 times 21 square root 3 divided by 4. So now very quickly, just to clean this up, again recall that the area of the segment, which is what we have to find out, is nothing but it is equal to area of the sector minus area of the triangle. So area of the triangle, we have seen, it is 21 times 21 times square root 3 divided by 2, and area of the sector, let's quickly take a look. What was the area for the sector? Area of the sector was 22 times 21. So we come back here. So 22 times 21, and area of the triangle actually was 21 times 21 square root 3 divided by 4, not by 2. So what we have here is this should be times 2, and area of the sector was 22 times 21. So at this point, Fred, it is just a calculation that you have to do. So area of the segment is equal to 22 times 21 minus 21 square times square root 3 divided by 4. So this is how, friends, we have to solve these questions that basically look for the area of segment. And let's say if we have a little bit more time, let's take a look at one more question, the final question of this webisode. So let's say a car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeter sweeping through an angle of 115 degrees. Find the total area cleaned at each swipe of the blades. Now this is very important, friends, that whenever there are no figures which are given, that we really understand what the question is and get the figure correct. So now what do we know about the wipers? These are obviously any automobile wipers. So cars, buses, trucks, you know what a wiper is, right? You're driving in a car and it starts raining or there is dust and you switch on the wiper and it just gets the water or the dust away. So why don't we first draw something? So let's say this is our, let's say this is the front glass of any vehicle. So we have drawn one of the blades like this, one of the wipers like this. Now what happens is this wiper actually sweeps across like this, right? It sweeps across like this. It cleans this amount of space. Now we have two wipers. So we have another wiper and they don't overlap. And it is also given that the wiper goes at a certain angle. Each wiper covers a certain angle. So in other words, friends, what we really have been given in a very complicated way is a pretty straightforward question of finding out the areas of two sectors. So now this is the radius, which is the length of the wiper blade, and that sweeps through a total angle of 115. So if this is theta, this is theta, this is also r. So total area that the wiper is cleaning in each sweep is equal to 2 times area of each sector. So which is given by pi r squared divided by 360 times theta. One of the sectors is given by this formula. There are two wiper blades. So total area is 2 times each of the sectors. So simply by putting the values in, so 2 times pi, r is the radius. It's important to understand the r is the length of the wiper blade because this is the one which is sweeping like this, right? So, and the length is given as 25. So r is 25, so it will be 25 square. So pi r square divided by 360 times, what is the angle that it sweeps through? It is 115. So if you simply solve this, and again like I have mentioned, if pi is not given, if it is not given in the question that we should take pi as 3.14, we are going to take the value of pi as 22 by 7. So this will become 22 by 7 times 25 square times 115 divided by 360 times 7, which is the 22 by 7. So this much, the unit of length is centimeter, this much centimeter square is the area which is going to be covered by both wipers in each sweep. So friends, these are some of the type of questions that you may be seeing on areas related to sectors and segments and how you would solve them. In the next webisode, we will probably take some more questions and find out how do we continue to solve such questions on segments and sectors.